All right, I'm going to start by taking a look at this table, and I'm going to see what's the pattern, like what's happening from row to row. Okay, now here I have a decimal, so I'm like, let me just skip that, right? Let me see if I can figure out the pattern without that row, and then I'll come back to it. So let's see what's happening to get from 5 to 10. Oh, I could say, oh, that's plus 5. But then is this plus 5? Oh, no, that wouldn't be plus 5. That doesn't work. Okay, 5 times 2 is also 10. Oh, 10 times 2 is 20. 20 times 2 is 40. So I can see I'm multiplying by 2, right? And let me just double check this. Is 2.5 times 2 5? Yeah. All right, so the pattern here is multiplying by 2. So does this table represent a linear or exponential function? Well, if I look, right, in an exponential function, that's where I have something, it's multiplying from one row to the next. So this table is exponential, right? That's what it is when it's multiplying. If it's adding from row to row, then it's linear. What is the starting point or y-intercept? Okay, remember the y-intercept. The y-intercept is always where the x value is 0. Like, that's always the y-intercept, right? That's always the y-intercept. So in this case, where x is 0, the y is 5. Okay, so this, right, you can even just put the number 5, right? But I want you to understand that it's always, always, always where the x is 0. Okay, if linear, what's the slope? Okay, it's not linear, right? Well, we're not going to cross it off because that's for all the things, right? So this one's exponential. What's the growth or decay factor? So in this case, the growth factor, this number is growing, and it's growing by a factor of 2. It's multiplying by 2 each time. Okay, write the equation that describes the relationship. Okay, so when I'm writing an equation for an exponential function, it looks like this. It looks like y equals a times b to the x. Now, the a is the starting point, so that's this, the 5. Okay, and the b is the growth factor, right? The b is the growth factor, which is 2, and to the power of x. Okay, so that's my equation. And now I'm actually going to check my equation, right? So I'm going to take this equation and I'm going to check it. So here's my equation, 5 times 2 to the x. And how am I going to check it? I'm going to check it using 2 rows from the table. So look, I'm going to choose this first row. This one's, or not this middle row, excuse me. I'm going to choose this row. This is an x value of 1 and a y value of 10. Okay, and I'm going to check my equation. How am I going to do that? I'm going to plug this in for x and I'm going to plug this in for y. So instead of y, I'm writing 10. Then I'm 5 times 2, instead of x, I'm writing 1. Okay, so then this is 10 equals 5. What's 2 to the power of 1? Oh, that's just 2. And 5 times 2, that equals 10. Looks great. Okay, then I'm going to choose another row. It doesn't matter which row I choose. Like, I'm not going to make my life difficult and choose the one with a decimal, right? Like, but you could. You absolutely could. Okay, if I chose the row with the 0, look, for example, if I chose the row with the 0, 2 to the 0 power would be 1, and then 5 times 1 would be 5. Oh, look, right? It would equal 5. Look, I'm going to choose this one, the last row. So it doesn't matter which row you choose, okay, but you're going to plug in and you're going to make sure that your equation is actually correct. So here I'm going to plug in 40 for y, right? It should work for all the rows if your equation is correct. And I'm going to plug in 3 for x. 40 equals 5 times, what's 2 to the third? Let's see, 2 times 2 is 4, times 2 is 8. Oh, and 5 times 8 is 40. So, looks good. Okay, so my equation is correct. How do I know? Because I checked it twice. All right, let's do one more together and then you're going to try. Let's see what's happening here to get from 12 to 7, from 7 to 2, and right away this 7's prime. Like, there's no decimals. This tells me right away that I'm going to be working with adding or subtracting because there's no way I'm like multiplying to get from 12 to 7, right? So right away I see 12, okay, and minus what is 7? Oh, minus 5 is 7. Minus another 5 is 2. Minus another 5 is negative 3. Minus another 5 is negative 8. Okay, looks good. Now here, look, here I'm adding and subtracting, so that is linear, right? Adding and subtracting is linear, remember this? Any sort of adding or subtracting is linear, and the exponential is where we see the multiplying or dividing. Okay, what's the starting point? Remember what I'm looking for, right? I'm looking for when x is 0, what's y? Okay, so in this case, when x is 0, y is 7. Okay, and I wrote it differently. Like, I don't mind if you just write 7. That's fine. But this is just your note for the rest of your problems. Okay, if linear, what's the slope? Okay, so this one's linear, so what's the slope? The slope is how the number is changing from line to line. In this case, it's decreasing by 5. Okay, and now we're writing the equation. Now, if I'm writing a linear equation, I use y equals mx plus b. And in the y equals mx plus b, the m is the slope and the b is the y-intercept, right? So that m is going to be negative 5 and the b is going to be 7. Okay, so there's my equation. And as always, I'm going to check my equation and make sure it's correct. Okay, so I'm going to check this equation with 2 different points. Let's see, let's choose the point with 0. Let's choose this one, 0, 7. I'm going to plug in 0 for x and 7 for y. Okay, so now I'm going to plug in 7 here for y. Negative 5 times 0 plus 7. Okay, negative 5 times 0 is just 0. And then 0 plus 7 is 7. So this is 7 equals 7. So that works. Okay, let's choose another point. We'll choose this bottom row, 3 and negative 8. So I'm going to choose 3 and negative 8. I could choose any row. If you want to like be a rebel, you can choose a different number. You can choose a different row right now and check it. While I'm doing this one, you can do yours. Either way, it should work. Okay, so this time I'm plugging in negative 8 for y. This is, negative 5 times 3 plus 7. Bring down negative 8. Okay, negative 5 times 3 is negative 15 plus 7, and negative 15 plus 7 is negative 8. So, again, my equation looks good. Everything looks good. This is how I check it. All right, so it's your turn. Remember, first you're looking, you find the pattern, right? Decide if it's multiplying or dividing, it's going to be exponential. If it's adding or subtracting, it's going to be linear, and then go from there.